Welcome to another semester. This is CS 696, big data, etc. Um, Usually the first order of business is to talk about the wait list, which used to be called crashing. Um, and as y'all probably should know by now, the, the waitlist system was created at the request of the student government, and it was made because apparently some instructors were abusing their power to let students in. And so the primary and only goal of the waitlist system was to make sure the instructors have no control over who actually gets into the course on the waitlist. The instructors have no idea who's on the waitlist. They have no idea what your order is. Um, and sometimes students are surprised because your order on the wait list can change because it's a priority queue, and the priority is determined by a number of factors. Um, and it's not just by when you add yourself to the queue. It's how many units you have and who have no bunch of other factors. And so you could be number one today, and tomorrow you could be number 5. And the good news, at least from my viewpoint, is I don't no longer have to worry about deciding who gets in, right? And all these quick questions. I was like, the bad news is that students then don't necessarily come to classes they're on the wait list for, and 2 weeks can go by and they'll show up 2 weeks later and say, "Oh, I want in the class." And it's like, well, you're like 2 weeks behind. Um, the other bad news is that so the first week, right, whenever a spot opens up in the class, a student's automatically added to the course. If you are already enrolled in a class at the same time, you automatically drop from that class, which means then someone else is added to that course and you get this chain reaction that bounces around. The second week, the instructor actually has to, as spots open up, the instructor has to, admit students. And what typically happens is a lot of students are like, well, I'm signed up for 4 classes or 5 classes, and it's like, oh, I'm not sure. And they'll wait until like the last day to drop classes. I do not add people on the last day. The reason is it gets dangerous. Why? What happens if, you decided I'm going to take these classes and they figure out you're on this wait list, and then 7 o'clock, the last add drop day is, a spot opens up, and then I add people, and that student gets added to this course. And they wake up the next day and they've got 4 classes, right? And then what? Well, then you work hard. Or what happens if they were enrolled in another class at the same time, and now all of a sudden, right? So it gets dangerous to add people at the last moment because they won't have time to, oh, wait, I really changed my mind. I don't want this class, or I do want this class, right? And to react to it. So it's like, no, the problem is, of course, people are waiting to the last moment, right? And so if you're shopping for classes, right, it's do your fellow students a service and decide as soon as you can. And keep in mind that next semester it may be you who want in a class, and someone else is waiting the last moment to let you in, right? And some instructors don't. after the first week, they say, "I'm sorry, but you're too far behind," right? And like, so just to reiterate, there's not. You can come up to me and say, "Oh, how would I get in this class?" It's like you wait, and there's nothing I can do. There's actually no one in the CS department that can change your ranking in the waitlist. There's no one in the CS department that can actually help you jump ahead, right? And that was the main goal of the waitlist. So they're like, even as graduate advisor, I have no, I mean, which is good because that's a nightmare, right? Like, you know, like people saying, "Oh, but my reason for it is better than your reason," and like, I don't know, right? So that's the wait list. And if you've been here long any length of time, you realize that our courses fill up, and then we have the long wait lists, and then after 2 weeks, all of a sudden the wait lists are either gone or very short. So yeah, yeah, just I mean, once you're on the wait list, it's like you can't do anything. Um, and yeah, just as seats become available the first week, you're automatically added. Um, and the second week, you know, instructors have to do something about it. Um, and so no, I can't add you, right? I mean, no, I'm not. This room holds, I mean, 60 people is getting big for a graduate course. Yeah, unfortunately, some classes they can like give you this gnarly assignment, like scare people off. And it doesn't happen here. Um, there are larger rooms, but it was like hard to get this time. Yeah, we'll see about that. And February 4th that's it, right? That's okay. This is a deadline to add or up classes. It's like a deadline for all kinds of things. If you want to graduate this semester, that's the deadline to sign up to graduate. And there's a bunch of other things that happen at the same time. It's like a monster deadline. So come February 5th, whatever courses you're in for the rest of the semester, right? Um, if you're an open university student, um, you're at the bottom of the wait list. What are the odds of getting in? You tell me how many people are going to drop the class and where you are on the wait lists, right? And then I don't know how many people are going to drop the class. Um, so I have no idea. So yeah, there's going to be one exam in the course. There's going to be 4 to 5, 6 assignments. Uh, you will. There's a project. Um, it's due the day of this. That's scheduled for the final exam for this course, and that's May 14th. Um, I allow students to work in teams of 2, not 3 or 4, 5 or 6, just 2. Um, the reason for that is I know when you've got larger teams, there's always students that disappear from the team. Um, and then everyone, like, okay, they make up for it. If it's a team of two, it's harder to disappear because you're going to choose that person a bit more carefully. Um, plus there are students who are working, really can't be on campus, work with students, and so they have to work alone, and it becomes sort of unfair. I mean, like you got one student working by himself, and a team of 10 or 5, like it's really hard to deal with that. So, and we'll talk more about that project later in the semester. Um, course website. Well, those of you that are enrolled in a class should have got an email earlier today. So I have a course website which I post assignments, I post my lecture notes, reading, the syllabus is on there. Right, and there are a couple of interesting things. One is the course wiki. This is there to, when you've got questions between classes, instead of emailing me and me answering the same question 10 times, you put it on the wiki, and then I can answer it once, and then everyone can see the question and the answer. And even hopefully there'll be times when a student will post a question and a student will know the answers. They don't have to wait for me to get to it. And it's a wiki, so anyone can edit the page. And often some people are a little nervous about that. So there's a special page called the Wiki Sandbox, which is just there for people to write things on. And there is a little edit button, and then you can start just editing, right, the text. And there are, some markups you can do, and there's a table right there to do the markups. Now, of course, when wikis first came out, anyone on the internet could edit them. And then, of course, trolls and various other people. Let's see, I'm not, oh, too bad. I forgot to bring any markers. I don't have any here. Thank you. So you need a username and a password to the first time you do it. I did it already, and so the browser knew it. Should be easy to remember, right? And that should be easy to remember. One's a password and one is the username. And it doesn't matter which you do in any order. So you just have to remember it's just the course number and the institution, right? And then you can, and of course I don't put this online because then we'd end up spending hours each day removing stuff that doesn't belong there. So there's a reading assignments, right? And I'm never sure how fast I'll go, so I don't put a reading assignments for the entire semester. I'll add as we go along. One of the things we will do, Later in the semester is we'll use Spark, running on AWS. And that, of course, is a commercial outfit, and they would like to charge money for that. But they have a program called AWS Educate, and so you can get $100 worth of credit to use on their machines. But you have to apply, and it can take some time for them to process it. So you should do it sooner rather than later, because if 6 weeks down the road when we get an assignment due on Spark and say, well, I don't have my account yet, it's like, yeah, but you've had 6 weeks to work on it. And so there's a link there to deal with that. I use several books, and actually we'll be using a lot of online references to various tools. So I'll add to that list as we go along. Both those books you can access online if you don't want to purchase them. The Spark book is online through Safari Online account that the library has, and there's a link there to the library, and then you have to give your SDSU ID, then you have to search for the book. The Python book is also another online version which you can use as a notebook, so you can download it and run the examples, etc. Is Spark Spark, which we'll find out later, is a tool for basically doing, not parallel processing, but using multiple machines to solve the same problem. So we can use a cluster to solve problems. It's like a framework, but it's a bit more than a framework because you have to have a cluster, and so you need a manager to manage a cluster, right? And then there's a bunch of other pieces of software which you can add to it to do various things on a cluster. And Spark is open source, so typically what you want to do is you download it to your local machine, and they develop there, get it working, and then just do the runs on AWS. It saves you money and it saves you headaches, because you can run it on AWS. It's a batch job. You run it, and if it doesn't go well, then you search the logs to try and figure out what went wrong. Whereas when you run it locally, you can do it interactively. So that's the website, syllabus, lecture notes. I didn't quite get the first assignment ready for today, but should be ready sometime this weekend, and I'll send people email when it's ready. So when I say tools, what do we mean? So we're going to use Python. It's a common tool to use in data science. Another tool is what's called a programming notebook, where you can actually embed text and code and run the code. And that's how you'll turn in your assignments. You'll put them in a notebook and then turn in the notebook and I can run it. And that points out one difference between data science and computer science, right? In computer science, you're just writing a program, you compile it and create an application, or it's a web application, or right. In data science, like, okay, no, you're processing data, so you also want to understand, what your goal was, right? So it's not just here's the end result isn't just here's a program, but it's here's the analysis, here's the explanation, here's a code that ran it, here's the data, right? And a notebook is a common way of combining all that into one place as opposed to what we normally do when the documentation's over here, source code's here, and the application's over there, right? Visualization, you've got 10 gigabytes of data. It helps to understand, some visualization tools help you understand what's going on, understand the data better. Statistics, again, you've got 10 gigabytes of data. You're not going to look at it by hand, right? It's just too much. We need to process it and analyze it somehow. Machine learning. We're going to look at, a streaming service in the sense of in big data, you have data coming from multiple places, right? For example, places like Amazon and the Postal Service, they basically know where all their delivery trucks are and what packages are in each one of them in real time. And so you've got across the country, you've got every one of those trucks reporting continuously its location. And so you get all the data streaming in. So how do we handle it? How do we process it in stream? Databases, I'm looking at Cassandra. Presumably, most of you are computer science students. And so you've had some experience with an SQL database. But there are other types of databases. Cassandra is a distributed NoSQL database. We'll see the history in a little bit, but Hadoop used to be, initially was a common program to process data on a cluster. But then Spark came along, and Spark is like faster and has more features and it's easier to use. So Spark is more common. As we'll see a bit later on, Python itself now has libraries we can use to run Python code in parallel on laptops or clusters. So we not necessarily tied to the structure that Spark imposes upon us. And there's a bunch of other tools that go along with Spark environment to look at some of those. So all the type of things that we're looking at. So yeah, you'll be installing lots of things. You'll want to install Anaconda on your machines. That gives you Jupyter notebooks. It gives you version of Python to use. Yeah, we're not going to do scaleless Spark anymore. We can use Python to do that. Assignments will be like, here's some data, here's some things. Answer these questions and explain the answers, right? And give me the code, and then I can run your notebooks, make sure the code works and gives you the answers you say they gave us. Um, so roughly, this is sort of the schedule. Each time I teach a course, I change it a little bit, and the long-term um, plan is to basically require a machine learning course or data science course this one, so I can then drop all that out and then do more tools. But currently the machine learning course is a 596, and you cannot require a 596 course from another course. But that will change soon. Or soon in the university sense, which is not soon in the normal sense. Yeah, I know. It's frustrating. It's like, um, yeah, we do notebooks. Notebooks are very common in the data science world. Um, and there are notebooks to run Julia and R and Python and even Scala and Java. Um, we're looking at visualization, mainly Python. Machine learning, um, one of the things you have to be aware of is Python is actually a very slow language to use for data analysis. Um, but in SciPy and in Pandas, basically what they do is they write all the code in C and then use Python to wrap it. And so as long as you're using just those algorithms, they're very, very fast, right? But you have to understand they're fast because you're running C code, not because Python's fast. I mean, Python is, when you understand how Python is implemented, it's like you realize that there's no way it can be really fast because it just wasn't designed for that, and it's not possible. Um, yeah, basically, people ask me the prerequisites. I mean, you're going to install these things on your machine, right? You're going to make them work. Um, and what course can you require to make that happen, right? I don't know, but and for those of you that have Windows machines, I don't have a Windows machine, so when you say I try to install this, it doesn't work. It's like, okay, you post it on the wiki and hope someone else sells it, because although their support for Windows for Unix devices has improved over the years. Um, and it's, what can I say, one of the founders of Paul Allen once apologized for using the wrong type of slash, right? Windows. And we're doing statistics, we do some math, right? And we're doing some machine learning. Um, so yeah, I mean, you install Jupyter via Anaconda, right? And if you're a Python person, you should realize that Python 2 is at the end of the life. Um, stop using Python 2. It has been over a decade since Python 3 came out, and people have been dragging their feet. And the basic problem is there are lots of libraries that weren't ported, and then if you depend on that library, what can you do? But I believe this year is the last year, and they said no more Python 2 support. And just to get started, we won't use it for a while, but you should just install Spark. Now, Spark 3.0 is in beta. Don't install it. I don't know. These are sort of standard, version, right, hierarchy. And when you go from X to X plus 1, that's indication that things that worked in X won't work in X plus 1, right? That's the main reason why you increase the integer number up by 1. So you're basically going to 3, you're saying that some things which worked on 2 will not work on 3. And I don't know which they are. Here's the books we're looking at. Like I said, there, you can go to the library, to get them online if you wish. Yeah, sign up for the Amazon. And you want to make sure that your Amazon account is connected to that discount, otherwise you can run. The AWS is fairly inexpensive computing power. And as long as you don't do something silly like leave your cluster running for days or put it into a loop in there and run, it's not going to cost